past, a lot of things have happened, and I will try to give a presentation first on what is the status in different countries, US, Europe, and China, and then I will also then look at what is the future prospect after LTE. So let's bear with me. There are quite a lot of slides. I will go relatively fast, but hopefully you get an overview of all this activity. So I'm the Chief Technology Officer for an organization that is bringing together two industries. And this industry is the automotive industry on one side and the telecom industry. We are working together to develop end-to-end connectivity solutions for the future mobility and transportation services. And we work in different domains, from technology, standards, spectrum issues, policy issues, regulations, go-to-market strategies, etc. So every 3 months, with the members, we gather in somewhere around the world. We work on different topics, which we call work items. We have 7 working groups, and these working groups are then publishing different reports and preparing also activities in their home country. So we are 134 members today. The kind of members that are joining are changing over the time. At the beginning, we were seeing a lot of mobile network operators and vehicle manufacturers joining, but today we see much more content-oriented members, such as here Maps technologies. We are seeing also Tencent, for example, a very huge data provider, content provider in China, and then also Apple as a handset provider has joined very recently. So among the members, we have 7 Korean members, not the least, obviously. Among these 7, Samsung is member of the board, and also LG, Hyundai Mobis, KT, and SK Telecom are very active, providing contributions to our different working groups. We work mainly in priorities. We are trying to align the different work items that we work on into different priorities, and this slide shows the new 8 priorities that we have set only a few weeks ago. They are comparable to what was previously there. Some of them were merged, some of them are explicitly mentioned. I'd like to point out that digital roads, for example, we as 5GA would like to be much closer to the road operators and making sure that the road operators understand what the automotive industry and the telecom industry wants to do. The trust is important, but also using the current mobile networks with the LTE technology and the future 5G technologies, the mobile edge, the future evolutions of the network, the interoperability of the different systems, the precise positioning, and a vulnerable users. All these form quite an extensive scope, and what I will do in this presentation is go to only a few of the priority areas. 5GA is not working alone. We are working with different partners. Some of them are partners in standardizations, others are partners in terms of spectrum allocation or interoperability and compliance. But also some, like 5G Forum and ITS Korea, are local members. We are partnering with them in order to understand what is happening in Korea, exchanging information, exchanging understanding of the different local markets, so that we can have a global approach within 5G. As I mentioned, we work with some public authorities. Some of them we have already signed cooperation agreements. Some are in the process of being more involved in the 5GA. The intention here is to engage and understand the road authorities, the traffic managers, the operations and the maintenance of the roads, so that they can eventually fulfill their objective of digitalization of transport, which is present in many different regions of the world. So now, why is 5G so important for the automotive? There is clearly a vision that 5G is much more addressed to industries. It provides many different options for the different industries, and obviously one of the industry is the automotive and the transport. It's really a Swiss Army knife. The automotive has different needs than other industries, and that's what needs to be reflected in the creation of the 5G standard. So 5G did not start from scratch. It started with the 10 years of experience that we have with LTE. In release 8 and up to the release 14, the LTE technology has progressed. A lot of current applications on the road are using the LTE network in order to provide services in terms of transportation service, traffic information, etc. This connectivity is usually a connectivity to a cloud or to a streaming service, but what came with release 14 is the vehicle to everything, V2X, which provides basic safety messages more on the short-range communication point of view. V2X was improved in release 15, and eventually now, as we speak, we are seeing the NR V2X being prepared in the standards into GPP. So we are expecting that by March 2020 to be completely frozen. So the V2X, what is it? What we want to be? We want it to be a comprehensive road safety solution and traffic efficiency solution. Comprehensive, that means that it includes the connectivity to the network, the cloud, and all the services in the cloud and in the backend, but also it includes the short range with the connectivity to the other vehicles, to the pedestrians, to the cyclists, or to the infrastructure. So there are two radio access technologies that are being used here. The conventional network, plus if we are talking about 5G, using the 3.5 GHz frequency bands, but the connectivity to the neighboring participants are usually done in another frequencies, the 5.9 GHz license extended band around the world. So, when we are looking at 5GA, we see a quite broad landscape of connectivity for the vehicles. We want to have a comprehensive approach, but we work piece by piece on different topics. So, goes to them. So, LTE V2X PC5 and NR V2X PC5 are very important. It's like the short-range connectivity. The connectivity to the vulnerable road users and the smart devices that are worn by the road users, the guaranteed quality of service and network slicing, the positioning, the trust and authentication of the different devices, the edge computing in order to reduce the latency of the services using the mobile network, and eventually also the participation and the information coming from Internet of Things. So all this needs to a comprehensive approach, which is actually offered with the V2X technology standardized in 3D. Now, I'd like to go back a little bit and then give a vehicle manufacturer's point of view on how this connectivity can actually complement what is already present on the car. And this is a very easy graph, very easy to understand because it shows at a distance different information that may exist. The first thing that we want to do in a vehicle is to inform the driver. And this information can be provided using the network, using a cloud-based information, warning or informing the driver about a possible risk ahead. Now, when we are coming closer to the vehicle, there are possibilities before seeing the danger, there are possibilities to warn the driver via V2V and V2I information. And eventually, when we are very close to the danger, when we really want to do a collision avoidance, we want to act on the vehicle. And these are three very basic principles that we have used over the last 20 years. Now, what we see over this last 20 years is that the border between acting and warning has been blurred a little bit. And so we see that the sensor is taking more and more, is improving more and more, and is taking more and more, is detecting more and more in order to warn the driver of a potential danger. The same is true for the information in the warning. So more and more, what we see is that information that can be provided by the network can be actually used in order to mitigate the risk. So over the last 20 years, the red box here, the red circle, has grown. So because we have invested a lot of money on the sensor and the in-vehicle sensor, so the same way the information, the border, the green border has shrunk, and leaving relatively little space for this V2V and V2I framework. So a lot of things can be done by V2 and V2A, a lot of things can be done by the onboard sensors. But for the automotive industry, it is essential that we keep this V2V and V2I at the 5.9 gigahertz. So a lot of the vehicle manufacturers within 5GA, they say, great, we will equip eventually our cars with 4G, 5G technology, but it has to be with the short-range communication with V2V and V2I. So this is a condition that we need to fulfill, and that's the reason why 5GA is so much focused on this kind of technology. Now, for the information, a lot of things have already been deployed. You can see in Korea, you can see in Europe, or in US. These technology use the network. This is the example of the E-Class. Since 2016, it is equipped with the V2N notification information for the real-time information. The backend is used in order to filter the data, aggregate the data, but also to ensure security and privacy. The great thing with that model in that architecture is that you can very simply add information coming from a traffic manager or from other source of information. On top of that, this architecture can be replicated all over the world very simply, and that's what the vehicle manufacturers are looking for. That means that already from 2016, a lot of different warnings have been provided by the mobile networks, giving information about events such as broken down vehicles, accidents ahead, hazard lights, etc. etc. Now, when we want to warn, this has to use the V2V and V2I on top of the information coming from the network. And that's why recently, a few 9 months ago, Qualcomm has announced a connected car reference design. And that connected car reference design is meant to show the way the V2V technology is going to be integrated into the chipsets, the automotive chipsets. And what is interesting is that this reference design integrates the LTE V2X that I talked about just recently. So now, one can also wonder why some OEMs are starting to question whether they should use SRC or they should use V2X. And so one of the vehicle manufacturers, Ford, has announced in January this year that they will equip all their vehicles with V2X by 2022 in US. And they gave a few explanation why they did that. So I took a part of them. First of all, the market trend. The market trend is clear. Most of the vehicles by 2025 will be equipped with 3GPP technology in their vehicles connecting to the network. For vehicle manufacturers, it's very important to have one connectivity platforms rather than many different ones. And so from an implementation efficiency point of view, they want to integrate the connectivity to the mobile network with the connectivity to the other vehicles, the short-range communication. They want to have a global footprint. They want to make sure that the V2X hardware, not the software, but the hardware is similar in every country in the world so that they can replicate it in these different regions. They reuse most of the information that has been done with the test or with the SRC. So most of the upper layers are actually a software layer, and so whether it's the SRC or ITS G5 or whether it's V2X, most of the services that are built on top of the radio are exactly the same. So that if Korean Expressway has done tests over the last 10 years with the SRC, most of these tests are actually, and especially the impact assessment tests are the same, and so we should not question these ones. And finally, Ford, what they want is to make sure that they embark in an evolution. We were talking about the 5G bandwagon earlier. That's exactly what Ford wants to do here. Now, let's take another point of view, the mobile network operator point of view, when they see that a lot of roadside units are being equipped along the roadways. And then they say, well, okay, road operators are installing roadside units, for example, the SRC roadside units along a long stretch of highway. This implies relatively high cost to deploy. They have a backhaul, they have to maintain. So a lot of capital expenditure and operational expenditure involved in the deployment of the SRC deployment. So at the same time, the mobile network operators do the same, but they do the same for another purpose. So the 4G cellular network is evolving, there is a higher requirements, and then there is densification of the cells, the small cells, etc., for the 5G deployment. So we end up with an opportunity to leverage the V2 and V2I with the roadside units to support also the 5G deployment. And that's really the point of view of the mobile operator, is that saying, why don't we put small cells but also provide the short-range communication that the road operator would like to have. And so there is really a win-win deployment approach for all parties in the transport domain to look at the possibility to embed PC5 roadside units and 5G small cells on the network. An example of this was provided by AT&T a few months ago, where they actually put roadside units on the top of a pole in a city, and that is very small and quite non-intrusive in terms of the landscape. Now I'll give a little bit of a viewpoint from China, what is happening in China, and I take one specific point of view is a city that is named Wuxi. It's about 150 kilometers from Shanghai. It has 3 million inhabitants, so relatively small city from the point of view of China. So already 3 years ago, they decided, okay, let's make Wuxi a model for city-scale deployment. They invested into the equipment in the intersections. So they ended up this year with 240 traffic intersections being equipped. And next year they are going to, this year they have the plan to put 400 intersections in total. This is done both using short-range communication in order to send information about, for example, the signal phase and timing, but also to relay information for to the central server or to the cloud. And using this installation, they have already experimented with different use cases that are displayed here. I'm not going to go all of them, but what is interesting is that there is a good balance between V2I use cases, V2V use cases, V2N, so using the network, and also pedestrian use cases. Very importantly, they make sure that beyond the installation of a road infrastructure, a roadside infrastructure, what they want is also to make sure that they have applications inside the vehicles. And they start obviously with the vehicle manufacturers, asking the vehicle manufacturers to integrate onboard units in their vehicles, but also with aftermarket devices, as well as applications that are fitted with specific apps. That picture is not taken directly in Wuxi. It's only taken. It's taken in Shanghai. It was only a few months ago, and that shows an event where they tested the interoperability of 26 different vehicle manufacturers with, I think there was 50 plus cars. These cars were running on an 11 kilometer real traffic area, so it was open to all other cars. And I can tell you, I was there, I showed the clear interoperability with all these cars being mixed into the traffic. And very interesting. Now what is great there is that there is really an impressive market ecosystem that has been driven by the government and by saying, okay, with a clear roadmap that they want to deploy V2X by 2020. Now, the US FCC did a fresh look very recently, actually last week, looking at the 5.9 gigahertz operations. As you may know, 5.9 gigahertz was reserved to the SRC. Now we are looking at an NPRM for this fresh look. The SEC wants to identify what is the possibility with this frequency band, and they are also giving quite a large part of this band to the Wi-Fi operation, and leaving only 30 megahertz to the vehicular systems. On top of that, they want to separate a V2X with 20 megahertz for the upper band, and then look at the next 10 megahertz for other systems. So, how does the market respond to these kind of things? They say, okay, we need just to make sure that we have both DSRC and CV2X on the roadside units. And so that's an example of early scale deployment in Atlanta. I'm not sure, I thought I had 30 minutes, but I am, okay. So let's try to speed this up. So how do they actually deploy these dual mode, dual active roadside units? They have roadside units in different intersections, so they want to fit 1,000 vehicles on the intersections. They they send a pattern map, and they have emergency vehicles which are also equipped with the technology. The antenna system is accommodating for DSRC and CV2X, as well as the 4G technology and 5G eventually when it comes. And the controllers are actually deployed on the pole so that it's easy to access. Optionally, they also relay BSMs between DSRC and CV2X, but that cannot be done when there is a large population, so that's done on the basis of the proximity intersection. So let me cover Europe relatively fast. I'm concerned about the timing. So as you may know, the European Commission has now objected to the framework that was, the regulation that was provided in the CITS. So as a background, this regulation had a few issues because it was only including ITSG5 short-range communication, so that means DSRC communication, and it was not looking at other technologies. So the Council of Ministers in Europe actually vetoed with a supermajority of 21 member states the regulation. And now where we are is that the only regulation that remains is the regulation related to the spectrum. And that's the one we are following at the moment. The spectrum is technology agnostic, and therefore we are, as a proponent of CV2X, allowed to deploy in the ITS band that is in the 5.9 GHz. Now, the big problem here is to know how does DSRC coexist between the different bands, and so we are looking at different techniques in order to have co-channel coexistence in the band. For this, we are organizing different interoperability events, and one of them are actually done this week in Europe, in Malaga, and we are promoting 5G, also the 5G strategic plans in Europe with different projects, but eventually with a lot more activities that will come with actual deployment of 5G along the corridors. Okay, I'll stop here because my time is up. So thank you very much, and I hope that we can conclude during the discussion.
Thank you.